The art in using alias or computer-aided design tools in general is trying to simplify a problem into the easiest block. This means trying to work with the most simplified geometry. That is the reason why we can work with a single span, but adjust the degree so we have enough control vertices to sculpt the shape of a curve we need. One of the main reasons is that actually this will make your life easier when passing the data to an engineer who can reuse or has to rebuild the intended design with their own software. So what you see here are two curves. They pretty much look the same. The upper one is a single span degree 5 curve. The lower is a 2-span curve. And to visualize the problem they have, we can actually select the curves and turn on the curvature graph. Middle mouse button adjusts the density a little bit, and there we see actually that with the EP curve, where we have an edit point on the curve, there is a small tiny kink in the curvature graph, while actually the single span curve has a really nice and smooth magenta slope. And the main reason you have to be careful about this one is that think about the math behind it. The upper curve is very easy to calculate, start point, end point, and some magnetic control vertices in between. The lower curve, we have a start point, a connection point, and an end point, and then the control vertices, and then the curve has to be blended here, made a transition to there. And that mathematically is possible, but as you can see, can maybe provide some problems. So mathematically, the upper curve is more simplified, but we still have the same shape. The lower example, mathematically, the problem is more complex. We have the same shape as well, but it is not really having the same simplicity. And specifically in computer modeling, the simpler the shape, or the simpler the approach, the easier adjusting it will be, the easier, the less problems you might have in passing the data to somebody. That's the main reason why I stress single span and work with the degrees.